morning, wherever you are around the world. This is the MEA vBrownbag with myself, Greg Robertson, hosting tonight. And tonight's presenter is Todd Simmons, also at TrainingVev on Twitter. So what we'll be going through is Objective 5 of the VCP-NV. Todd's graciously come forward and said that he was willing to do an objective for us. So he said, yes, please, Objective 5, which is great. So we're trying to clear off all the objectives of the VCP-NV as soon as possible, because I know a lot of people have been communicating with myself and other vBrownbag hosts saying that they're finding these quite beneficial, because it seems a lot of people are going to the VCP-NV. So that's great. We're going to try and get them done as soon as possible. If you do want to do, if anybody on the webinar live or even watching these recordings wishes to present an objective, then please get in contact with anybody from the vBrownbag crew, and we can try and organize it. We're always looking for presenters, even if it's not the VCP-NV. So yeah, if you're interested, please do get in contact. Todd did that. He got in contact with us, and we tasked him with an objective pretty quickly. So yeah, going to try and get through as many as possible, and we are booked up next week also. I think it's actually Objective 7, because we missed out Objective 6. We will go back to Objective 6, but yeah, Objective 7 was already tasked to somebody, so we're going to do that next week. But yeah, if you have any questions, ask them in the question area as per usual. You can ask them on Twitter with #vBrownbag. And for those people that are watching the recordings, if you enjoy this or something, you want to spread the word, please use the #vBrownbag. Yeah, we don't get paid for this, so if it can get more viewers, then that's always great. But yeah, that's enough of my inane waffle. So I will make you the presenter, Todd, and again, thanks for agreeing to present tonight.
I'm sure, but did I just hear we're not getting paid for this?
No, oh no, too late. You've already agreed on it.
Oh man.
Oh no. Jeez,
all
right. I know.
I'm going to share my screen out, but I'm wondering, here we go. Change the screen. Here we go. How's that?
Yes, I can.
Perfect. Yep. All right. So guys, this quick brown bag session during my lunch break here back in the States is going to be on logical switching and a little bit of a teaser, maybe a little bit of some information on VXLAN as well to help out. A little bit about myself. Been in IT since 1997. I do a lot of instruction for Cisco, EMC, VMware, VCE, and I'm also a NSX driver, not just an NSX implementer, but a driver. So if you are familiar with the Acura NSX or the Honda NSX, I believe, as it is in Europe, you can always reach me at TrainingRev on Twitter if you ever have any questions. And I also blog about NSX-related topics at nsxinsight.wordpress.com. You can find me there. So what we're going to be doing in this brief session is I'm going to try to give you a demonstration of all of the individual topics that we have for the exam, related to switching at least. Okay, so we'll jump in the demo environment, and then I'll go ahead and give you some live demos. We'll go through a little bit of a vSphere distributed switch configuration, although I will tell you that in my environment I already have it configured, so you won't see me create a distributed switch here. We'll talk a little bit about the benefits of logical switches. We'll go through exam objective 5.1, so I'll show you how to create a logical switch. And then I'm going to give you a quick primer on ARP. For those of you who are network engineers, this should be certainly a bit of a review. For those of you new to networking, ARP is something certainly important when we talk about switching and how virtual machines communicate with each other in a VXLAN environment. So we'll take a look at that. I'll give you a primer on VXLAN, and then we'll cover Objective 5.2, how to configure VXLAN, and I don't think we're going to have time to cover configuring and managing bridging, but I'll also give you some additional resources where you can find some more information. So a little bit about our lab environment. The demo environment that I'm using is VMware's lab environment. And so the way that VMware has it configured is just a little bit different than what you see here. Typically, what we like to have is a dedicated management cluster with 3 nodes in it. And each one of those nodes is going to have an NSX controller installed on it. And each one of those ESX hosts is going to be outfitted with at least 2 NICs, 2 physical NICs. Here I have VM-NIC 0 and VM-NIC 1. In our actual environment, we only have 2 physical hosts for the management cluster. So what we'll do is we'll install 2 NSX controllers on one host and 1 NSX controller on the other. Ideally, you would want to have at least 3 hosts and a dedicated management cluster. We also have a dedicated compute cluster that we'll be using. So there's 2 nodes in that cluster. And then I have a third cluster, which actually only has 1 ESX host in it. So we have what we call compute cluster A, and then we have a compute cluster B. As far as the configuration goes, in our environment, what we'll be looking at, we've already configured the 3 networks that you typically have within a distributed switch environment. We have one for management, we have one for vMotion traffic, and then we have one for storage. And then we're also going to be using a distributed switch for our VXLAN environment. So that's the only one that's missing from this particular slide. I've also set up a lab environment here at work that I use for NSX demonstrations. We won't be using that today, but I did publish some information on how to set up your own environment for NSX. Just a few of the details here. I like to use the HP ML110s. They're quiet, reliable, and pretty flexible with adding in additional physical network adapters, so they make a really good component in an NSX lab environment. And then, of course, working at Cisco, I have a lot of Cisco gear, which really works out nice. It's nice to have physical equipment within your environment because, you know, there certainly are some things that we have to do in a physical environment to prepare for NSX. We want to check out things like MTU size. We might want to go in and configure multicasting within our environment. And so having some physical gear and knowing how to configure that is certainly very helpful. Always need shared storage as well, unless you're going to host virtual machines in maybe a vSAN type environment. I guess you could use a virtual machine for storage as well. I always use a physical box for shared storage. So to provide a little bit of NFS storage, in my lab environment I use a QNAP device. So the blueprint itself, the objectives that we want to cover, Objective 5.1 and 5.2. The first objective, pretty straightforward. We're going to create and administer logical switches. So I'll show you how to set up the IP address assignments. When I talk about IP address assignments, I'm really referring to the IP addresses of the VTEPs. Okay? So, you know, we've got to come up with a range of IP addresses that we're going to use based on the number of subnets that we have within our environment. We'll then go in and create some logical switches. In our environment, we'll create more than one logical switch. We'll talk about the control plane mode. So we've got 3 different control plane modes that we can support. Unicast, hybrid, or multicast. So we're going to dive into the control plane modes that are supported and how those would be configured. I haven't set up an NSX Edge gateway in my environment. I'm in the process of doing some video recording, so you guys kind of caught me right in the middle of a setup here. So I'm going to show you what I've got up to this point. So we won't see anything related to the NSX Edge gateway. I will show you how to connect it, but I just don't have one that we'll be connecting to, at least at the moment. I'll show you how to disconnect and connect virtual machines to a switch. Very easy to do. We'll also test logical switch connectivity, and the way that we do that is simply by pinging virtual machines, ping a virtual machine running on one ESX host to a virtual machine running on another ESX host. And then we also have some additional tools that we can use to verify that the logical switch is working properly. And then finally, we'll get an objective 5.2. So we'll show you where VXLAN needs to be configured within your environment, what hosts you're going to be using for VXLAN. We'll talk about the physical network requirements. There are some physical network requirements that you need to be aware of. Specifically, the MTU size on your physical switches is going to have to be changed to be at least 1,600 bytes. And I say at least because it can be more if you want it to. So if you have jumbo frames already enabled within your environment, you may be okay. We'll also talk about configuring teaming policies for your implementation. You guys are familiar with teaming policies on a vSwitch or a distributed virtual switch. And so we have to take those teaming policies that we use into consideration when we configure NSX as well. So we'll talk about the teaming policies that are actually supported. And then we'll talk about those transport zones. The transport zone is essentially where we're going to be running our VXLAN traffic. Right? So how do you expand, edit, or add to a transport zone? Well, typically what we're going to be doing with our transport zones, we're going to be adding clusters to them. Okay? So we'll show you how to make some changes to the transport zones. And then finally, preparing those VXLAN tunnel endpoints or your VTEPs on the clusters. We'll show you how to go through and do that within the environment. All right, so configuring IP addresses. You are going to need IP addresses for your VTEPs. Now, the number of VTEPs that you're going to have within your environment is going to be based on a couple of different factors, right? How many ESX hosts do I have within my environment? And on those ESX hosts, how have I configured adapter teaming, right? Am I using Ether channel within my environment? Am I using LACP? Am I using just a single uplink within my environment? Am I doing failover? Okay, so the teaming policy that you select is going to have the largest impact on the number of IP addresses that you need for your VTEPs. Okay, so we'll, in our environment, talk about creating static pools. So we've determined the number of VTEPs that we're going to require. We'll, in our environment, we'll be using one per ESX host. And if we come back here, I've got 5 ESX hosts within my environment. So I'm going to need 5 VTEP IP addresses. Remember, our physical management cluster only has 2 hosts, not 3. So there's a total of 5 hosts within my environment. And so we're going to need 5 IP addresses. So show you how to configure those. Now you can use DHCP. We won't be using DHCP in our environment to assign IP addresses to VTEPs. We're just going to put in a static range of IP addresses. Okay. All right, so static pools. We're going to create a static range as I had mentioned. Okay. I'll also show you how you can go in later on. Let's say, for example, that you used a static range and later on decided, you know what, I don't want to use that IP address for my VTEP anymore. I'll show you how you can go in and manually change the IP address for your VTEP. Remember, a VTEP really is a VM kernel port, right? So it's pretty easy to go in and change the IP address of a VM kernel port. Okay. All right, so let's take a look at our lab environment real quick. I'm going to give you just a demo here of how we have it set up. Okay, so as I mentioned, we have 3 clusters within our environment. We have Compute Cluster A, we have Compute Cluster B, and then we have a Management and Edge cluster. And as you can see, within our environment, I've got a total of 5 hosts. 2 in the Compute Cluster, 2 in Compute Cluster A, 1 in Compute Cluster B, and then 2 hosts in the Management and Edge cluster. Now again, ideally, you would want to have 3 hosts in your Management and Edge cluster. And the reason being is because we're going to deploy 3 controllers, and in my environment right now, 2 of these controllers are going to be running on a single ESX host. So ideally, I'd like to have 3 ESX hosts so that each one of my controllers would be installed on an independent host within the management cluster. All right, let's take a look at the networking within the environment over here. You can see that I have two switches. I have a compute switch. I have a management switch. Just take a couple of, take a look at the settings over here. Again, in our environment here, compute VDS. MTU size is set to 1600. And we'll just verify it over here for the management switch. And settings here, MTU size set to 1600. Looking good over here. Okay. I've also, within my environment, I've already gone ahead and configured the VTEPs. So let me show you that real quick. I've done a couple things already, actually. Here we go. We talk about the host preparation. We want to make sure that the VIBs have already been installed within our cluster. You can see here that the VIBs have already been installed. VXLAN is enabled on each one of these hosts. You can see the 5 hosts that I have within the environment. Okay, and we'll go over to the logical network configuration under the VXLAN transport. We'll see that I'm using, for my environment, I'm using IP addresses from a pool. So I'm just going to expand this out so you can see what those IP addresses are. You can see in the management cluster, each one of my ESX hosts has its own IP address. The compute cluster is going to be the same. Compute cluster A, and then compute cluster B. So you can see the IP addresses of all of the VTEPs within my environment. Okay. All right. So adding and removing logical switches. So remember, a logical switch is essentially, for us, going to be a port group, right? So think of scenarios when you would be creating a new port group within your environment. In the lab environment that we have, I'm going to come back to the demo here. In our lab environment, the logical switches that we've created are for specific applications. So I've got a web tier, an app tier, and a database tier. And then I've got a Todd tier apparently over here as well. Okay, so I'm going to go ahead and just delete this logical switch here real quick, just so I can create another one here for you. So I'm going to go ahead and create a new logical switch. I'm going to name it demo, and then I'm going to select a transport zone. Now, in my environment, I only have one transport zone, and that transport zone spans all of the clusters in my environment. So let me go ahead and create a new switch called demo. The control plane mode, we're going to talk about that in greater detail in a few moments, but I've got 3 options here. Multicast has not been configured in my environment to support VXLAN, so I'm not going to be able to choose that. Unicast is going to be your safest bet, right? I'm going to let all of the control plane activities be handled by the NSX controller. And then hybrid, again, is something that is certainly supported, something that we can do within the environment. We just have to make sure IGMP snooping is supported in the switches that we're using within our environment. And I haven't configured that yet. So we're going to go with a safe bet unicast. And I'm just going to choose OK to create that logical switch. All right, so I've created this logical switch, and I told you that it was essentially a port group. So what I'm going to do is I'm going to come back out in the vSphere client here. We're going to go over to networking, and I want to show you this port group. You see right here the demo port group that I created. Right, so this is the VXLAN. The VXLAN ID is 5004. You'll see that that VXLAN ID 5004 for the demo logical switch that I created, it got created on both the compute virtual distributed switch and it was not created on the management edge switch down below here. Okay? And that is something very specific to my environment. So I want to show you this because this is pretty important. That transport zone is going to determine, let me come back here, I'll show you this over here. And we're going to go over to transport zone real quick. Here's my global transport zone. And right now, in my transport zone, I'm going to go ahead and choose Add Clusters. As you'll notice, I actually don't have the management and edge cluster in my transport zone, nor do I have compute cluster B in my transport zone. Right now, I only have compute cluster A in my transport zone. So what that essentially means is any logical switch that I create in my environment is only going to be created in that first cluster. So I'm going to change that so that you can check this out. All right, so let's update this transport zone. I'm going to go ahead and add clusters. Now you remember when I showed you where the demo logical switch was created, that port group, it was created only on the first cluster, compute cluster A. I'm going to go ahead and check management and edge cluster, and I'm going to check compute cluster B. Give it a few moments here to update, and then I'm going to come back out home. And I think I gave it enough time. Let's take a look. Cool, so demo is up here, and demo is now down here. Okay. All right, so adding and removing a logical switch is important. Where that logical switch is going to exist, as I showed you, is really based upon the transport zone that's been configured. So again, coming back to it, in my environment, we've got a logical switch that I've created, or multiple logical switches. The last one that I showed you was the demo logical switch. And that demo logical switch is created in the global transport zone that I created. And that global transport zone, the membership of that transport zone, includes all of the clusters within my environment. Now, here's something else that I could do, right? I've got an environment here with 2 compute clusters and 1 management and edge cluster. I might decide, you know what, I'm going to create another transport zone, and I'm just going to call it my compute transport zone. Wait a second here. I'll just call it compute. Compute's fine. Compute TZ transport zone. All right, going to go with unicast. And I'm just going to choose these guys right here. Okay, now I'm going to go in and we'll go back to logical switches. Go ahead and I'm going to create another logical switch here for compute. TZ. And notice I have the ability to select the transport zone here. So I'm just going to select that compute transport zone. It defaults to unicast. That's what I selected for that transport zone. And then I'm going to go ahead and click OK. And then we're going to come back out here, go over to networking. And then you'll see here in the compute cluster. Right, the compute cluster distributed switch that I've created, I now have the logical switch that's been created. Right, so pretty neat stuff. Okay. All right, so adding and removing logical switch is pretty easy to do. Connecting a logical switch to an NSX edge gateway. Logical switches are great, but they're layer 2, right? So if I have any routing that I need to get done, that logical switch isn't going to take care of any routing for me. So if we go back to our demo environment one more time, there we go, and we're going to go into our NSX configuration. And look at our logical switches. You'll see that I've created multiple logical switches here, a web tier, an app tier, a database tier. Each one of these tiers is on a different segment ID and is going to be backed by a different network segment, right? So that means that the IP subnets are going to be different for web, app, and DB. So in order for me to be able to communicate between those, I'm going to need to be able to route traffic, right? So I can connect these individual logical switches to an edge gateway as an option. I can connect them to a router. I haven't added in any edges yet. The way to do it would be to right-click on the logical switch, and then you could go in and add an NSX edge. So pretty straightforward. Okay, deploying services to a logical switch. Now, in order to deploy services to a logical switch, you need to have at least one or more third-party virtual appliances installed within your environment. We don't have that, but I can still show you in our demo environment here where that would be configured. So you would take any of your logical switches, you right-click on them, and then you can go in and add service profile. We really don't have anything configured within our environment, so we won't be able to bind to any specific service profiles here. Cool. Now that I've created some logical switches, one of the things that you're going to want to do is connect your virtual machines to your logical switches, or better yet, disconnect them. So in Objective 5.1, we've got a quick demonstration here for that. So let me come back out to the lab environment here. And as you can see, real easy. Just right-click on the logical switch itself, click on Add VM, and it'll give you a list of all of the virtual machines within your environment, and you can go ahead and select a virtual machine. I'm going to just check this one for now. I'm not using it for anything else. Choose Next. It'll ask you which VNIC you want to use, and then you can go ahead and just check it. So very easy to add, or remove for that matter, virtual machines from a logical switch. Now, once a virtual machine has been added to that logical switch, it's because this is something that you should be familiar with, that you've seen in the past. If I look at the settings of the virtual machine, and that logical switch is just a port group, right? You see it as that virtual wire port group, and you'll see it right here. So I'm just looking at the settings of a virtual machine, and you can see that the VNIC is connected to the port group. And in fact, you could also do it this way as well. So if you didn't want to connect the virtual machine by going into networking and security, you could do it at the individual virtual machine as well. All right, so testing logical switch connectivity. There are certainly a lot of ways in which you can test logical switch connectivity. One of those would be simply just to power on one of the virtual machines and then ping another virtual machine within your environment, right? So open up the console of a virtual machine and just ping it. There are also some other tools as well. Let me go ahead and show you what else we got here. Okay, here we go. So you can see here in our environment, I've got a couple of different virtual machines. I've got app SV01A, which should be powered on and does not have an IP address. Let's take a look at web. He's on 5001. That's interesting. Sorry about that, guys. This is the joys of live demo environments, right? I was expecting to see an IP address here on this particular host, so now let's just open it up and see what's going on with it. I know I'm not crazy. I did see that that virtual machine was powered on. And the console just doesn't want to come up. Oh, there we go. Okay, cool. So again, one of the things that you can do is just run a ping. So I know that the IP address of this machine is 172.16.10.11. So if I ping web 2, 172.16.10.12, I should get a response back. Never can tell. All right, cool. Good stuff. So that's a quick and easy way to make sure that you're able to communicate with two virtual machines within the environment. And here we go. All right. Okay, so I wanted to just do a quick whiteboard with ARP, and I'm not quite sure how this is going to work out, but let's give it a whirl. I have this little application called VBrownbag, which is for the Mac, but this is my first time using a Wacom pad, so please bear with me. All right, let's see here. Move this up here. There we go. Okay. All right. So here is a host, and here is another host. All right. Good stuff. And we're going to put a switch in this environment. And this host, and we'll just use physical host for now. Connected to this switch over here, and this host connected to this switch as well. So they're connected to the same switch. Pretty basic environment. And this guy's going to have an IP address that ends with .11, and this guy's going to have an IP address that ends in .12. Okay, so this is host A, and this guy over here is host B. All right, so for ARP, we have the IP address. Host A wants to communicate with host B. What I need to find out is the MAC address. All right, so we do an ARP request. An ARP, right? I have the IP, I need to get the MAC address. Now, in our environment, we're connected to a switch. These guys are on the same subnet, so a broadcast is going to go across the wire. It's going to say, hey, who has IP address .12? And host B is going to say, ooh, me, that's me. and sends back its MAC address. Ooh, this drawing is rough. I'm sorry, guys. And once the MAC address goes back, we can communicate at layer 2, right? Pretty straightforward, right? We're using a logical switch within our environment, right? So instead of this being a physical switch down at the bottom, we're just going to say that this is a logical switch. Okay? So 2 virtual machines connected to the same logical switch. What's going to happen is A is going to send out a request for the MAC address of B. It's going to send out an ARP request. That information is going to be in the logical switch's MAC table. And so we're very easily able to establish layer 2 communication between the 2 virtual machines connected to the logical switch. But we want to make this a little bit more exciting. This is rough. All right. Here we go. There we are. All right. Let's see, how can we make this more exciting? All right, we'll do 1. That's not what I wanted. Here we go. 2, 3, 4, 5. These are VMs up at the top. We're going to do some hosts down at the bottom. Let's do 1, 2. These are ESXi hosts. 3, 4. And just for the purposes of our setup, I'm going to say that these virtual machines are connected here. And this guy is connected here. This guy is connected here. And this guy is connected here. So down I'll just put ESX hosts. Up at the top, I'll do VMs. Come on, you can go to the top. There we go. And then way down on the bottom, I'm going to put in 2 switches. Oops. And these switches are actually going to be connected to each other. Okay, so without even talking about VXLAN, let's just make the assumption that we've got a couple of hosts here in the environment. And we've got virtual machines A, B, C, D, and E. And then ESX hosts 1, 2, 3, 4. All right. These virtual machines are going to communicate with each other. They're going to be on a... Oops, ran out of room. There you go. You get the idea. This is a port group right here. And all of these virtual machines are in the same port group. Okay. So for these virtual machines to communicate with each other, let's say that A wants to communicate with E, right? So A wants to communicate with E, all in the same port group, all in the same subnet, right? Same port group, same subnet. So if A wants to communicate with E, we'll make the assumption that A does not have the MAC address of E. A is going to send out a request. The request is going to hit the switch. Remember, this is an ARP request. Now, that switch most likely will have the MAC address, but if it doesn't, then past that broadcast, it's layer 2. He's going to respond back with its MAC address. Okay. So we're going to switch this up a little bit. Instead of being a port group here, we're going to make this a logical switch. And this logical switch, we're going to give it a VLAN segment ID or VXLAN segment ID of 5,000. That's where we start with our logical switches. Okay, there we go. So logical switch 5000, all of the virtual machines are connected. In our particular environment, they're all powered on, not sending any traffic. VM1 wants to send, or VMA wants to send to VME. Let's just say that in this particular environment, A sending to E, A does not know the MAC address of E. Okay, so A doesn't know the MAC, it's got the IP, doesn't know the MAC. It's going to ask the logical switch. Now remember, that logical switch runs inside of the kernel. So you've got a logical switch on each one of these ESX hosts. Okay? Now, what's going to happen is the host is going to send an ARP request. We're going to be looking at the logical switch, which has a MAC table to determine, what's the location of virtual machine E. What is the MAC address of virtual machine E? And so if that doesn't already exist inside of the logical switch, we need to be able to go out to the NSX controller. Remember those 3 controllers we installed? All right, so we're going to go to the NSX control. The NSX controller is going to say, oh, you want to communicate with virtual machine E. Well, virtual machine E is on ESX host 4, which has a VTEP IP address of, I don't know, something .251. So A sends its traffic directly through the ESX host, right, onto the VXLAN through its VTEP, across the switch, wow, this is rough to do, into this ESX host VTEP, and over to, wow, and over to E. Okay, so I want to talk about, and I'm going to go ahead and just kind of kill this because this is a little bit too difficult to actually draw here. So I want to talk about a couple of different things. First things first, how does the logical switch get the MAC address? Well, the logical switch gets the MAC address when you do an ARP, right? If the logical switch doesn't have the MAC address, the logical switch, or the ESX host, is going to communicate with the NSX controller. And hopefully the NSX controller has the MAC address. But what if the NSX controller doesn't have the MAC address of the virtual machine you're trying to communicate with? Right? If the NSX controller doesn't have the MAC address, then that's where we get into a situation where we have to do a flood. All right? And so, man, I really wish I had a real whiteboard here. Let me just try this one more time. I'm just going to do this real quick. Two virtual machines. Here's a couple ESX hosts, 2 ESX hosts. Let's say that these ESX hosts, the 3 ESX hosts. 3 virtual machines, A, B, C. I'm going to put an NSX controller over here. A and B are connected to this ESX host. C is connected to this ESX host. Nobody's connected to the ESX host in the middle. I'm creating a logical switch with a segment ID or a VNI of 5000. When A and B get powered on, this ESX host, which has a VTEP, this one has a VTEP, this one has a VTEP. This ESX host right here, ESX1, is going to send something called a VTEP report to the NSX controller that says, hey, NSX controller, I am participating in logical switch VNI 5000. I actually have 2 virtual machines that are connected to that logical switch, A and B. Now, even though ESX2 is in the transport zone where VNI 5000 would exist as well, it doesn't have any virtual machines on VNI 5000. So if I look at the NSX controller in the VTEP report, and I'm going to give these guys some IPs here, .51, .52, and we'll just say .53. This NSX controller over here is going to say, hey, look, I've got for VNI 5000, the VTEP supporting that right now are .51 and .53. Why? Because A and B are over here, and C is over here. VTEP for .52 isn't listed because there are no virtual machines that are using that VNI on that ESX host. And the reason I mention this is this is important because let's say that A wants to get over to C. A's got the IP address of C, but it doesn't have the MAC address. You know, to do layer 2 communication, we need the MAC address. So A is going to check its logical switch, right? MAC address isn't there. So what happens is we go all the way out to the controller. But let's just say for this particular scenario, C had just come up. So the controller didn't quite know about C just yet. So what's going to happen is we're going to do a flood. All right, we're going to do an ARP flood. And who we send that flood to, who we send that ARP request to, is going to be based on the membership of that VNI. So VNI 5000, the members, VTEP 51 and 53. It's very efficient, right? Okay. Let me clear these pages. Let's come back. We're getting tight on time here. A couple other things I want to cover. All right, so that was just a quick overview of ARP and kind of some of the things going on in the background with logical switching. So the control plane, I'll go ahead and show you where that is. This VM is just having a rough day. Here we go. Working security, switches. Edit. So I'm editing settings on this particular logical switch right now. So 3 control plane modes, right? Multicast, unicast, and hybrid. Okay. So the example I just gave you was unicast, but I showed you how efficient unicast control plane traffic is, right? We're not going to send an ARP request out to everybody. We're only going to send an ARP request out to those logical switches or those ESX hosts who are members of a logical switch, meaning they actually have virtual machines on that logical switch. Right? So very efficient. Now, multicast is very different, right? Multicast requires that you configure your physical infrastructure to support it. And one of the things that's really neat about multicast is it completely avoids the controller, right? So multicast in an environment says, you know what? I'm not going to ask the controller. I'm going to send multicast traffic out. So if I need to do an ARP request, I'm going to go ahead and just send out multicast traffic. You know, the advantage potentially is that you're taking or you're offloading traffic from the controller. Another advantage is I'm not relying on the controller. A disadvantage, you could say, is that the controller itself now is not maintaining a VTEP or a MAC table, right? Another disadvantage would be now you're relying heavily on your physical infrastructure, which is, you know, kind of one of the things that we've been trying to get away from, right? But those are the options that we have. Right? So that's how you would change the control plane. Some quick slides on VXLAN, and I'll make this deck available to you guys as well for those of you who are interested in it. But VXLAN, one of the things that I like to show with this is that what you really care about in each layer is what is the source and destination? So, I want you to look just specifically at that, right? So for layer 2, right, when we talk about layer 2, the source and the destination are going to be the MAC address, right? Layer 2 frames use a 48-bit MAC address, source and destination, okay? When we get into layer 3, we're doing IP version 4, right? We're looking at packets. We're looking at not source and destination MACs, but source and destination IPs, right? We take it a step further. We get up into layer 4, and now we're not looking at source and destination IPs or source and destination MACs, but we're looking at source and destination ports, right? And then if we go one step further, we start talking about VXLAN. Remember, we're doing layer 2 here, right? And so we're encapsulating layer 2 traffic. So we're taking that Ethernet frame and we're encapsulating it into a VXLAN frame, right? So you'll see the same thing here, right? Take a look at it. You see the outer header of the VXLAN frame. You see the inner header of the VXLAN frame. I'm sorry. You see the outer header. Yep. You see the inner header, and we're actually looking at outer MAC, inner MAC. So the outer MAC is for the VXLAN frame. The inner MAC is going to be for the virtual machine. So our outer MAC is going to be the VTEP. Our inner MAC is going to be the virtual machine. Outer IP address is going to be the VTEP. Inner IP address is going to be the virtual machine. And take it a little bit further. If you use ESXi commands, take a look at one of your vSwitches. Over here, I just ran an ESXi command looking at a distributed virtual switch in my environment. I'm actually looking at the distributed virtual switch I created with, the logical switch I created with a network segment ID or VNI of 5001. And you'll see here's your VXLAN information. The inner MAC is the virtual machine. The outer MAC is the VTEP MAC. Outer IP is the VTEP IP address. All right, so where do we install a VXLAN? Well, within your environment, you want to make sure that you've created a distributed switch to support the VXLAN environment. So I'm going to come back over to my setup. Cancel out of here. For networking, I've created 2 switches that I'm supporting VXLAN within my environment. The compute virtual distributed switch and the management virtual distributed switch. So within your own environment, and this is a very simple environment, you're going to have this at a bare minimum. You've got to identify where you're going to be installing VXLAN. Okay, so once we identify the distributed switch, as you can see in this slide, where we're going to be using VXLAN within our environment, you'll go in and you'll create your VTEPs. And again, when we created our VTEPs, we use them from a pool, a dedicated pool, although you could assign them statically after the fact, or you could use DHCP for the IPs of your VTEPs as well. And then below, we're looking at our generic IP fabric, the switches within your environment, how they're going to be connected. Speaking of switches, we do have some physical network requirements. As I mentioned, the big requirement for us, if you're using unicast, then you just need to make sure that the VXLAN frames are going to be supported. So you need to have at least 1,600 bytes. One quick and easy way that you can do it, you can connect into a switch. Here I connected into my Cisco switch, and I'm just looking at the interfaces on my switch. I'm looking at the MTU size of those interfaces. You can see that I've got an MTU size of 9,000. All right, preparing a cluster for VXLAN. One of the things that we do is we install the VIBs. In order to support VXLAN, we've got to make sure that the VIBs have been installed, so we prepare the hosts. That is done coming over to networking and security, under installation, going over to host preparation, right? And you can see VXLAN is enabled within my environment here, so I'm good to go. It's done very early on at the installation, right? The next thing that we're going to do is we're going to configure VXLAN networking. In here, you identify the switch that's going to be supporting VXLAN. For us, in this particular cluster, the Management and Edge cluster, I'm using the Management Edge Virtual Distributed Switch. That is the distributed switch that's going to be carrying my VXLAN traffic. I double check to make sure that the MTU size is set correctly. And here it says that I'm using DHCP, but to use an IP pool, you're just going to click the radio button to use an IP pool and then just create an IP pool. Uh, 5.2 talks about the appropriate teaming policies that you'll use, and I know we're starting to run out of time here. We've only got a few slides left. So, as far as the teaming policies go, if you have access to it, I think the VMworld session from this year on virtual distributed switches, vSphere distributed switch best practices was very good, something that you should take a look at. Talks a little bit about the teaming modes for individual ESX hosts. But there are some that are not supported, and so I just want to drop this table in here for you. Some of the information in this slide shows you how many VTEPs you'd end up with based on the teaming mode that you select. Know that LDT mode is not supported. This is directly from the NSX documentation today. I showed you how to add a cluster to a transport zone early on in our demo today, so I won't repeat that. We talked about the preparation of VTEPs on a cluster. Again, coming back, setting up VTEPs by configuring VXLAN networking. I want to drop in a couple of commands that I like to use with VXLAN and the NSX controller. One of the cool things that you can do is you can look at the VTEP table on a controller. In fact, I may still have it up here. Here we go. I think it's still here. Yeah, I get a putty session in the back. Yeah. So as I mentioned to you, you can actually take a look at what VTEPs are currently supporting a particular logical switch. So in my environment, I've got a logical switch with a VNI 5001, and these are the two VTEPs that are currently supporting that logical switch. So this is my VTEP table. They're actually right up here, 51, 52. Very cool. All right. A couple of additional resources that are available to you. I put in a list of all of the blog resources that I've been using as of late or have been using over the last year that I find incredibly useful. So those are listed here. A couple of other things. Don't forget that VMware has been doing a lot of work publishing VMworld sessions related to NSX, publishing a lot of introductory either videos or presentations. Chris McCain has done some. Scott Lowe has also made many of his presentations available through SpeakerDeck. So there's a lot of good stuff out there. There's also instructor-led training that's available from VMware, 2 classes right now. There's the Install, Config, Manage class, which prepares you for the VCP-NV. And then, of course, there's also an Experts Fast Track class. One of the things that gets overlooked pretty often as well is how powerful VMware's hands-on lab environment is as well. If you find that you have to do a demonstration or you want to get some hands-on experience with NSX, reach out to the hands-on lab. And it takes a while to get NSX set up in your lab environment if you're using physical equipment. You know, the hands-on lab is great because in about 3 minutes you can have the entire environment up and ready to go, and you can start getting some hands-on. So that's going to be a great tool for preparing for the VCP. And that's it, in addition to documentation. So I hope that was informative. I hope that was helpful, guys.
that was awesome. Yeah, guys, if you have any questions, you can stick them in the question area. If not, then, yeah, if anyone's actually watching the recording of this, then, yeah, you can always stick questions through. I'm fairly sure that Todd won't mind you sending them questions. Obviously, he does have a day job, so don't expect him to get back to you straight away. But he's at TrainingRev, R-E-V, on Twitter if you want to ask him any questions or send him feedback saying thanks for presenting. That was great.
Yeah, you can always reach out to me on Twitter, and I really apologize for the horrible Wacom drawing there, guys. I'm going to see if I can do a little bit better with a blog post on that.
No worries. Okay, doesn't look like any questions, so I won't keep you longer in your lunch, Todd. Thanks for presenting. That was great. So you got through the first two pieces. I don't know at some point if you want to come back and do the last piece. You're always more than welcome. And then, guys, next week we have Manfred Hoffer doing Objective 7. So, yeah, if you're on the webinar, then, yeah, you're more than welcome to come back next week and also spread the word. So, yeah, I think that's about it. Again, thanks, Todd, for presenting. Guys, I'll try and get the recording up as soon as possible. I'll start encrypting it now, and hopefully I can get it up pretty soon. And yeah, I'll hopefully see you guys next week. And as I said, if you want to present on any of the vBrownbags around the world, then please get in contact with one of us, and then we can get you on. Cool.
All right, I'm signing out. Thanks for having me. I appreciate it.
No, more than welcome.